Ever get that feeling of information overload when you're trying to grasp a complex research paper?
Oh, absolutely.
We're diving into one today,
Okay,
but don't worry, we'll break it down together.
sounds good.
It's called LEGO-GraphRAG, Modularizing Graph-Based Retrieval-Augmented Generation for Design Space Exploration.
Wow.
A mouthful, right?
It is, but the core idea is actually quite elegant.
Okay.
It's all about helping AI understand and reason using structured knowledge, like a map of information.
So it's like giving those large language models, LLMs,
Right.
the ones that power AI chatbots and writing tools, a set of directions to navigate the world of facts.
Exactly.
Okay.
See, while LLMs are great with language, they sometimes struggle with factual accuracy. They can even hallucinate, meaning they confidently make things up.
Wow, that's both impressive and a little unnerving. So how do we ground their reasoning in reality?
That's where knowledge graphs come in.
Okay.
Think of them as highly organized networks of information, where stacks are connected in a way that makes sense.
Okay.
This paper explores how we can use these knowledge graphs to help LLMs reason more accurately.
Okay, so we're essentially teaching AI to think logically using these knowledge maps.
Right.
And that's where the Lego part comes into play.
Precisely.
Okay.
The LEGO-GraphRAG framework takes a modular approach,
Right.
breaking down the process of retrieving relevant information from a knowledge graph into smaller, manageable steps.
So instead of trying to solve the whole puzzle at once,
Yes.
we're breaking it down into individual pieces.
Yeah.
I'm starting to see how that could be helpful.
It's a bit like searching for an answer in a massive library.
Right.
Instead of wandering aimlessly, LEGO-GraphRAG helps us narrow down our search to the most relevant sections,
Okay.
then guides us to the specific page and paragraph containing the answer.
That's a great analogy. It sounds way less overwhelming than trying to sift through a whole library at once.
Yeah.
So walk me through these modules. How
Okay.
do they actually work?
The research focuses on two key modules: subgraph extraction and path retrieval.
Got it.
Subgraph extraction is like identifying the relevant books in our library analogy,
Right.
narrowing down the vast knowledge graph to a smaller portion that's directly related to our question.
And then path retrieval is about finding the exact answer within those books.
Yes, it's about tracing the connections between concepts within the subgraph to pinpoint the specific information we need.
So if I ask a question like, what is the capital of France?
Right.
The subgraph extraction module would identify the section of the knowledge graph related to countries and capitals.
Exactly.
And then the path retrieval module would zero in on the connection between France and Paris.
Exactly. Now, here's where it gets even more interesting.
Okay.
Each module can use different methods to achieve its goal.
Okay.
They can either rely on the inherent structure of the knowledge graph, think of it like following the Dewey Decimal System in a library,
Okay.
or they can use what we call semantic-augmented methods.
Semantic-augmented. That sounds a bit more complex.
Yeah.
What does that involve?
It's like having a librarian who understands both your question and the content of the books.
Okay.
In this case, we're using additional AI models to understand the meaning behind the words and the relationships in the knowledge graph.
So it's adding a layer of understanding on top of the structured knowledge.
Yes.
Interesting. But wouldn't that make things slower and more computationally expensive?
That's a great question.
Yeah.
And it leads us to one of the key insights of this research.
Okay.
There's a constant tension between accuracy, speed, and computational cost when designing these systems.
Sounds like a classic engineering challenge.
It is.
And this LEGO approach helps researchers explore those trade-offs more effectively.
Absolutely.
Okay.
By breaking down the process into modules,
Right.
they can mix and match different methods, experimenting with different combinations of structure-based and semantic-augmented approaches.
Okay, I'm starting to see how powerful this modular approach can be. But before we dive into those specific combinations and findings,
Right.
let's take a step back.
Sure.
You mentioned that LLMs sometimes hallucinate facts.
Yes.
Why does that happen?
Oh.
Aren't they supposed to be super intelligent?
What you see, it's almost like they have all the words,
Right.
but haven't quite grasped the underlying meaning.
That's a great way to put it. LLMs are trained on massive amounts of text data,
Right.
but that doesn't necessarily give them a deep understanding of the real world
Right.
or the ability to reason about facts in a nuanced way.
Exactly.
So they might be able to write a grammatically perfect sentence about the capital of France,
Yes.
but not truly understand the relationship between a country and its capital?
Precisely.
Oh,
And that's why this research is so important.
okay.
It's about bridging that gap between language and knowledge.
Okay.
helping LMs move beyond simply generating text to actually understanding and reasoning about the world.
Okay, that makes sense. So back to the LEGO-GraphRAG framework.
Yes.
You mentioned that the researchers tested different combinations of structure-based and semantic-augmented approaches.
Uh-huh.
What did they find?
Well, one of the most surprising findings was that using the most complex AI approach for every step
Right.
wasn't always necessary,
Okay.
or even the most efficient.
So sometimes a simpler approach is actually better.
Exactly. They found that a hybrid approach,
Okay.
using structure-based methods for subgraph extraction and semantic-augmented methods for path retrieval, often struck a good balance between accuracy and efficiency.
It's like using the Dewey Decimal System to narrow down your search in the library,
Yes,
then asking a knowledgeable librarian to help you pinpoint the exact information you need.
that's a great analogy.
Yeah.
It highlights the strengths of both approaches.
Right.
Structure provides a framework for efficient search,
Okay.
while semantics adds a layer of understanding that can lead to more accurate results.
Now, you mentioned earlier that there are different types of semantic models. Can you explain the difference between those end-to-end models, PEMs,
Right.
and the large language models, LLMs we've been talking about?
Imagine you're driving to a destination.
Okay.
An LLM is like a high-performance sports car,
Okay.
powerful and precise,
Mm-hmm.
but requires a lot of fuel and maintenance.
Okay.
EMs, on the other hand, are like reliable sedans.
Okay.
They offer a good balance of efficiency and performance,
Okay.
making them a more practical choice for many everyday tasks.
So choosing the right semantic model is a bit like choosing the right vehicle for a trip.
Exactly.
Depends on the specific task and the resources you have available.
Exactly. And the research highlighted that LLMs,
Okay.
while powerful, aren't always the best choice,
Okay.
especially when dealing with massive knowledge graphs and real-time applications where speed is critical.
So there are real trade-offs to consider,
Hmm.
but even with the best tools and strategies,
Yes.
there are still challenges, right?
Yes,
You mentioned something about multi-hop reasoning earlier.
that's right. Think of it like this.
Okay.
If finding a single piece of information is like finding a specific location on a map,
Okay.
then multi-hop reasoning is like planning a route with multiple stops.
Okay.
It requires connecting the dots between several pieces of information,
Right.
following a chain of reasoning to arrive at the answer.
So it's like solving a complex puzzle where the clues are scattered across different parts of the knowledge graph.
Precisely. And this research revealed that even the most advanced GraphRAG implementations
Okay.
still struggle with those more intricate reasoning tasks. It's an area where more research and development are needed.
That makes sense. It sounds like an incredibly complex problem to solve. Now, I'm curious about the specifics of their research.
Go.
What kind of knowledge graph and queries did they use to test these different LEGO-GraphRAG implementations?
They chose Freebase, a massive knowledge graph containing millions of entities and relationships.
Wow.
A real challenge for these AI systems to navigate.
Okay.
And to test different levels of reasoning complexity, they used 4 distinct query datasets.
So they really put these systems through their paces. And did they find any particular strategies that stood out as especially promising?
Yes, the hybrid approach we discussed earlier,
Okay.
combining structure-based extraction with semantic-based path retrieval,
Right.
performed exceptionally well,
Okay.
achieving a balance of accuracy and efficiency that other approaches struggle to match.
So it seems like that combination might be a key direction for future research in this area.
Absolutely. It's a testament to the power of the LEGO-GraphRAG framework.
Right.
By breaking down the problem into these modular components,
Right.
researchers can experiment with different combinations of techniques,
Okay.
leading to new and innovative solutions.
This has been a fascinating deep dive so far. We've covered a lot of ground.
It has.
From understanding why LLMs sometimes hallucinate facts to exploring the clever LEGO-GraphRAG approach for enhancing their reasoning abilities.
And we've seen that there are real challenges and trade-offs to consider when designing these systems.
Right.
It's not just about creating the most powerful AI. It's about finding the right balance between accuracy, speed, and efficiency.
Which brings us back to you, dear listener. Imagine you're tasked with building a system that needs to reason about complex information.
Okay.
Knowing what we've discussed today, what factors would you prioritize? Accuracy, speed, or cost-effectiveness?
That's a good question.
Or is it always going to be a delicate balancing act?
That's a great question to ponder. And it leads us to another intriguing aspect of this research.
Okay.
While they focused on factual knowledge graphs,
Right.
imagine applying similar approaches to other types of information.
It's like we've been focusing on teaching AI to read encyclopedias. But what if we could teach them to understand social dynamics, financial trends, or even the creative process?
Exactly. Could we use similar graph-based approaches to help AI navigate the complexities of social networks?
Right.
Or predict market fluctuations based on patterns of financial data?
The possibilities are mind-boggling. It's like opening up a whole new dimension of AI capabilities.
And it highlights how this research is just the tip of the iceberg. We're only beginning to explore the potential of combining structured knowledge with the reasoning power of LLMs.
This LEGO-GraphRAG framework seems like a powerful tool for unlocking that potential,
Yes,
offering a flexible and modular approach to knowledge graph retrieval.
it certainly does. And for you, the listener, this deep dive offers a glimpse into the exciting world of AI reasoning and the challenges researchers are tackling.
It's a reminder that AI isn't just about building bigger and smarter models,
Right.
but also about understanding how to effectively connect those models to the vast stores of knowledge we already have.
It's about finding the right tools and strategies
Right.
to help AI navigate the complex world of information and make sense of it all.
We've seen that there are trade-offs to consider.
Yes.
Accuracy versus speed, complexity versus efficiency.
Mhm.
And there are still hurdles to overcome, especially when it comes to multi-hop reasoning.
But the progress being made is truly remarkable. And as this research continues to evolve, who knows what incredible breakthroughs await us?
Perhaps we'll see AI systems that can not only understand factual knowledge, but also grasp the nuances of human emotions, cultural trends, or even artistic expression.
Imagine AI collaborating with artists to create groundbreaking new forms of art, or helping scientists develop personalized medical treatments tailored to each patient's unique needs.
The possibilities are truly endless, and this deep dive has given us a taste of what might be possible in the future of AI reasoning. So, as we wrap up, we invite you to reflect on what you've learned today. What sparked your curiosity?
What new questions have emerged?
And most importantly, how might these advancements in AI impact your own work, your own life, your own understanding of the world around you? We encourage you to continue exploring these fascinating topics, to delve deeper into the world of knowledge graphs and AI reasoning, because the future of AI is being shaped right now, and your curiosity, your insights, your questions are all part of that journey. Thanks for joining us on this deep dive.